Good morning, guys. Just wanted to go through pages 25 through 29 with you, give you some help on how you could figure out some of this stuff. So if you look at page 25, the first question says identify one use for the mineral garnet. So we're looking for a use for garnet. So we are going to refer back to our page 16 in the back of the reference tables. All you have to do is find garnet and locate the use. Number 2, identify one mineral in this rock sample that can scratch the mineral olivine. So it can scratch the mineral olivine, which means it's harder than olivine. So unfortunately, there's no olivine on this chart, so we have to go to our reference tables. We find the hardness of olivine, which is 6.5. Once we have that, we figure out which of these minerals can scratch that. So once you figure out that the hardness is 6.5, you look up all of these other minerals and you figure out which one of these can scratch it. There may be multiple answers. Number 3, all of the 5 minerals listed on the table are silicate minerals because they contain the elements silicon and oxygen. State the name of one other mineral on the properties of common minerals chart that is a silicate mineral. So our silicate minerals contain silicon and oxygen, and they want us to state one other mineral, okay, that is not here. So when we do that, we look on our reference tables, we look for silicon and oxygen, and once we do that, we can find an additional mineral that is not listed on this chart. Okay, number 4, on the grid above. So this one you're going to do on your own, and you're not going to put that on the Google Doc, but it is a good skill to practice. So on the grid above, you're going to construct a bar graph that represents the hardness of these minerals. So again, creating a bar graph using the hardness on your reference tables, and you can create a bar graph. Which mineral shown on the grid would be the best abrasive? Well, we have to figure out what an abrasive is. So an abrasive is something that can scratch off other materials. So an abrasive could be used in cleaning to scratch off things. It tends to be a mineral that is harder. And then you're going to state one reason why it is a good abrasive. Okay, let's take a look at the next page. Okay, looking at page 26, describe one characteristic of the minerals in group A that make them different from the minerals in group B. So looking at this chart, again, don't forget to read the top. I'm just going through this quickly with you guys so you can work on this on your own, just a little guidance for you. But if you take a look at mineral A and you take a look at minerals B, you're going to look at how is quartz, potassium feldspar, and plagioclase feldspar different than amphibole, pyroxene, biotite mica, and olivine. So the best thing to do is to have out your reference tables. You're going to look for quartz, plagioclase feldspar, and potassium feldspar, and figure out how those are different than some of the other minerals, okay, compared to these. Number 7, identify one other mineral found in some samples of diorite that is not shown in the diorite sample in the diagram. So one other mineral that is found in diorite that is not shown. Okay, so take a look at diorite. Diorite, they're showing you that it has plagioclase feldspar, that it has amphibole, and that it has biotite mica. So what I'm going to do is I'm going to go to page 6 of my Earth Science reference tables, which is right here. I'm going to look for diorite. I'm going to go down to the bottom, and I notice there's a little bit of quartz, plagioclase feldspar, biotite, and amphibole. So again, we're looking for something other than these 3. Number 8, a sedimentary rock has the same basic mineral composition as granite. Describe one observable characteristic of the sedimentary rock that is different from granite. Well, we should know that granite is an igneous rock. We should also know that on our reference tables, we put on all the different observable characteristics. So igneous rocks are glassy, have crystals, and gas pockets. where our sedimentary rocks have fossils, layers, and cemented fragments. So with that in mind, this question is asking, a sedimentary rock sample has the same composition as granite. Describe one observable characteristic that this sedimentary rock would have. So we're talking about an observable characteristic of sedimentary. Okay, number 9, you're not going to be able to do on the Google Doc, but you can draw 5 lines on here to the symbols of minerals that are commonly found in granite. So again, we go to granite on our reference tables. We go straight down. These are the minerals that are found in granite. And now we're going to draw lines for granite. So to our granite, we're going to draw lines to any of the minerals that connect to it. Okay, moving right along to page 27. So now we're going to be dealing with sedimentary rocks, a metamorphic rock, and an igneous rock. So we're using our rock cycle, which could be on this page, page 6. And we may have to use some of our identification charts on 6 and 7. So number 10 is asking identify sedimentary rock X. So if I go to sedimentary rock X, one of the things that they're telling us is the diameters or the range for the sediments. Once I know that I'm looking at a clastic sedimentary rock, and I'm going to see which one of my clastic sedimentary rocks have that particle size, and that will be my answer. Number 11, we're going to identify metamorphic rock Y. Well, metamorphic rock Y has a composition of quartz, feldspar, mica, and amphibole, but it has a banded texture. That is very important. Once I go to my metamorphic rock chart, I'm looking for the one rock that shows banding. And number 12, complete the table below with the descriptions of observable characteristics used to identify granite. So we are going to go to our igneous rock chart, which is found on page 6. We're going to look for granite, and we have all these different characteristics we can use. Turning right to page 28. Number 13, state the possible grain size in centimeters for particles found in sample 1. So let's go to sample 1. Sample 1 is mostly clay. It is a clastic rock. The name shale. So we're going to figure out where our shale is on our sedimentary rock chart. Again, it's very important to know which chart you're looking at. So this question, since they are giving us particle sizes and they're telling us it's clastic, our clastic rocks are found in sedimentary. And if it's shale, all we have to do is work our way back to find the sample size. Number 14, write the rock name of sample 2. So sample number 2 is only made of mica. Its grain size is microscopic, and what's very important is that it's telling us it's foliated. Since it's foliated, we know we're dealing with a metamorphic rock, right? Our foliated metamorphic rocks. So now we're just going to write the name of our sample number 2. Again, what is important, that it's only made of mica. And then finally, number 15, write a term or phrase that correctly describes the texture of number 4. So sample number 4 is the rock granite. If we go to our igneous rock chart and we look for granite, all we have to do is work our way back underneath the texture column. And finally, rounding out our last page, we are going to base our answers to this flow chart or concept map. First question, we're going to talk about the rate of cooling at A that forms an intrusive igneous rock. We're going to compare it to, or contrast, cooling of B. So compare and contrast, basically, the extrusive rock to the intrusive rock. So if you have your reference tables and it has your notes on it, you should know that your intrusive rocks cooled slowly with magma underground with large crystals, and your extrusive rocks cooled quickly on the Earth's surface, creating gas pockets, a glassy texture, or small crystals. Number 17, give the grain size range that would be placed on flowchart C. So if we follow our flowchart, we have magma, we know the cooling rate, it's an intrusive rock, It has a coarse texture, and now we can figure out the grain size. Once we go to coarse texture, we can figure out the grain size by looking under crystal size. Be careful, crystal size and grain size are interchangeable. And then finally, number 18, state one igneous rock could be placed at flowchart at D. So if I look for D, which is all the way down here, we know this rock was formed by lava. It cooled quickly. It's an extrusive rock. It has a glassy texture. Once we know it has a glassy texture, we now know our answer. There can be more than one answer though for that one. So we're looking for our glassy texture. Okay guys, hopefully that helped. I will be posting more videos to help you with some of these worksheets. This assignment is due today at 3 o'clock. Please do the best you can to get it on that Google form and turn it in using Classroom. If you haven't signed up for my Remind, if this is the ICT class watching, ICT is 8-10-10, okay? And it's at ICTEAR, okay? Have a great day, guys.